Hello everyone, welcome back to OpenGL. I just wanted to quickly integrate the lighting structures that we have with our UBO, or with a new UBO, just so we didn't have to take care of this in the video that will be dedicated to the tangent spaces, which is normal mapping part 2. So we're just going to be essentially using the UBO that we created in the past 2 videos and putting all these light structures, so for the directional light, the point light, and the spotlight, and we're just going to be putting arrays of them to replace our uniform arrays that we already have in the Fragment shader. Before we do start, I did have 2 commits to GitHub before this video. One was just some upkeep, or just something I missed in the UBO code, which was this line to actually advance the cursor in the stack in the advance array. So we advance the offset but not the cursor in the element stack. Once again, that's fixed on the GitHub page. And then also I had to make the utility methods for in the namespace. They all have to be inline, just because otherwise they're going to be recognized as duplicate methods. Alright, so for the code for this episode, we are going to start in the default header for our shaders, and we're going to add 3 things here. First one is just going to be the define for the max number of point lights, so hashtag define max point lights. This should be defined already in object.fs, so just make sure you have the same value. It's 20 and then 5. So max point lights 20, and then same thing for the spotlights, define max spotlights 5. Alright, and then we're actually going to put our UBO right in the default header. So we're going to be able to use these structures just because we can put that in the UBO. So layout std140, that's our format, uniform lights, and we're going to call it lights. Make sure you remember this name. So we're first going to have our directional light, so dir light, then int number of point lights, and the array size will be max point lights. So this is just going to be replacing our uniform arrays in the Fragment shader here. And then same thing for the spotlights, so int number of spotlights, spotlights, and the size will be max spotlights. Alright, perfect. Now in the Fragment shader, what we can do is we can go ahead and delete the uniform values that we have for the directional light, the point lights, and the spotlights, and then also the define macros, just because we put that in the default header. And then we're going to add some new uniform arrays. So what happens is in UBOs we cannot actually pass in samplers, so we actually have to remove these from the structures. So in all 3 lighting structures, the directional light, we have to remove the sampler 2Ds and the sampler cubes from the corresponding structure, just because you cannot pass them in through a UBO. You have to pass them in through just a regular uniform variable. So as a result, in the Fragment shader, we're going to have the uniform arrays are going to be in here. So we'll have uniform sampler 2D dir light buffer, then uniform sampler cube, and it's going to be point light buffers, and it's going to be an array of size max point lights, and then uniform sampler 2D spotlight buffers, and that will be an array of size max spotlights, just like that. Alright, and because we changed this, we now have to go into our wherever we reference these buffers, so in the shadow functions, and we just have to update how we call them. So in calc dirlight shadow, we just have to change dirlight.depth buffer to just dirlight buffer, and that change is going to be for the 2 instances that I see right here. And then in calc point light shadow, what we're going to have here is we have to, wherever we call point lights at idx.depth buffer, just change it to point light buffers, and it's going to be at idx, so the indices will be the same. So just like that, and then I believe there is this closest depth here that we do not actually need. And then the same thing for a calc spotlight shadow. So we call spotlights at idx.depth buffer 2 times. So we just have to change it to spotlight buffers at idx. Just like that. And like that. Alright, that should be all for the fragment shader. Now we're going to go into light.cpp, and since we're moving everything into UBO, we can actually remove all these calls of the shader.set uniform variables. So as a result, we are going to have to just remove all of the calls to these functions within the dirlight.render, the spotlight.render, and pointlight.render. However, you do have to keep the calls to when we set the buffers, because those are still standard uniform variables. However, you will have to change the names here. So it becomes dirlight buffer, or whatever name you have with the uniform samplers up here. And then we'll do something similar for the point lights, and all we have to do is just delete all of the shader.set values, and then change the name of the buffer to, or of the uniform name of the buffer to point light buffers, then open square brackets, close quotes, plus standard to string, pass in the index, and then plus a closing brackets, just because this has to be a string, and just format this as whatever other name you have here. And then same thing for the spotlights. So delete everything up here except for the depth buffer. And then the name becomes spotlight buffers, open square brackets, plus standard to string idx, plus, and then a close square brackets as a string. So that's what that should look like. Alright, now we're going to move over to scene.h, the scene header file, and we actually have to set up the UBO to be able to be used in the scene. So we'll just be, we'll have the UBO object just contained in the scene, just for, so it has its accurate scope, or in relation to the program. So include, well, we first have to include it, so it's going to be include graphics / uniform memory.hpp. And then we're going to add the UBO as an attribute here. So it's going to be UBO : UBO, then light UBO. And then I also wanted to add 2 more attribute variables down near the light vectors. It's going to be just to hold the number of spotlights and point lights, just so we have a variable here. So unsigned int number of spotlights, and then unsigned int number of point lights. The reason for this is because when we pass these values into the UBO, since it's required in the up here, we need a pointer we need a pointer, and we can't just say pass in a reference to pointlights.length, because that's a function call, so it doesn't work like that. Alright, and then we need to change the function definition for, or the function signature for the prepare function, which is the last function we call before actually running the main loop. This is after all the instances have been generated, and I think that this is the best place to actually set up the UBO, because all the lighting values will be set, so we won't expect any changes as of now. As of this point in the tutorial, we're just looking at static lights. So we'll set it up in here. So all we need to do is just pass in a standard vector of shaders, so a list of shaders that will just be used, that we will bind the UBO to. And in our case, we're only going to pass in the default shader. Alright, so now in shader.cpp, what we have to do is go to the top first, and we're going to have a few macros just to mirror the macros in the default shader header. So it's going to be hashtag define max point lights as 20, and hashtag define max spotlights as 20, or as 5. Now in the constructors, we need to actually initialize the UBO because it has no default constructor. And all we can do there is just call the light UBO constructor and just pass in as 0 as the binding position. And then just do that in each of the shaders or in each of the constructors that we have. All right, now in scene.prepare, I'm going to find this function right over here. Make sure you update the signature so it has the list of shaders. And now we are actually going to set up the lighting UBO. So we're going to call the light UBO constructor again. So light UBO is equal to the UBO constructor. So UBO.UBO. And we're going to pass in 0 as the binding position, and then we will take care of the structure in a second. It's going to be tedious, so I just wanted to get through the actual the binding process, and then we will set all the values after. So we're going to attach the UBO to the specified shaders. So for shader S in shaders, light UBO.attach to shader, pass in S as the shader, and the name will be lights. And this name here has to be the same as what we set in the default header. With the case, it is case sensitive too. All right. Now we want to actually set up the memory. So light UBO.generate, light UBO.bind, light UBO.init null data, pass in GL static draw, then light UBO.bind range. This will just we talked more about this in the last video. This will just essentially just tell OpenGL what area of memory this UBO will point to. And then we'll write the initial values, which is light UBO.startWrite, and then we will take care of the directional light, the point lights, and the spotlights. And then after all that, we have to call light UBO.clear to unbind it. Alright, so let's get some of the tedious work out of the way right now. So we'll start with the constructor call. So in our uppermost structure element, we're going to mirror this up here. So we're first going to have our directional light structure, then an integer, then our point light, then an array of point light structures, then an integer, then an array of spotlight structures. All right, so we'll start with the UBO new struct, and we can pass in a vector of elements into this function here. So we're going to have a UBO type vec3 for the direction, then UBO type vec4 3 times for the ambient, diffuse, and specular lighting values, and then UBO new call mat with 4 columns and 4 rows, and this corresponds to the light space matrix. All right, then we're going to have our scalar, so UBO type scalar, and this corresponds to the number of point lights. Then UBO new array, and the size of this array will be max point lights, and then it'll be the array element will be a new struct, so UBO new struct, and we'll pass in a vector of elements once again. So in this one, we're going to have a UBO type vec3 for the position of the point light, then UBO type vec4, that 3 times for the 3 lighting values, and then UBO type scalar 3 times for the attenuation constants, and then UBO type scalar, and this one is going to be for the far plane, which is right here. I'll add comments in the commit just so it looks a little better. Alright, and then similarly for the point lights, or for the spotlights, we're going to have a UBO type scalar for the number of spotlights. Then we'll have a UBO new array. Size is going to be max spotlights, and it'll be a UBO new struct. And the list will contain several values. So UBO type vec3, 2 of those for the position and direction. Then UBO type scalar. This is going to be for the cutoff and the outer cutoff. Then we're going to have UBO type vec4, 3 of those for the colors, the ambient, diffuse, and specular. Then UBO type scalar times 3 for the attenuation constants. Then UBO type scalar times 2, and this one is going to be for the near and far plane. And then UBO new call mat 4 and 4, those are the dimensions, and this will be for the light space matrix. Alright, so that's the first part of the busy work. Just essentially, if you didn't want to watch that, just mirror the structure of our light structures in the shader and also in the light header file. In the directional light, we forgot to have the UBO type scalar for the far plane. Alright, so now we should get to write this stuff. This is going to be super fun. Trust me, it's going to be so fun. Alright, we'll just essentially go down in procession. I might just do a speed through this in the video, but just all you got to do is just pass in the corresponding variables sequentially. So we start with the directional light, so light UBO dot write element. The template variable will be glm vec3, and we're going to pass in a reference to dirlight dot direction. Then we're going to have the 3 lighting values, and make sure that you're passing in one the proper template variables, and then also make sure that you're passing in references, so pointers to these variables. Alright, and then we need to write the far plane, so light UBO.write element, and this is going to be a float, and the value for this one will be a reference to dirlight.br.max.z. So if you remember, we kind of have a bounding region to define the directional light's kind of frustum. So the far plane will be the maximum z coordinate of that bounding region. And then we write the matrix, so we're going to call light UBO.write array container. And the container will be of type glm mat4, and the actual array element type will be glm vec4, denoting the 2 template variables. And then it's going to be a reference to dirlight.lightSpaceMatrix, and the number of elements will be 4. This is just a function that we use to define how to write a container that had an array. Alright, so then for the point lights, we want to set our class variable number of point lights is equal to the minimum value, so standard min, template variable of unsigned int, and this is the minimum value of point lights dot size and max point lights. The purpose here is we don't want to go, we don't want to go over the maximum number of point lights, even if there's more point lights in the vector, and we also just want to take the smaller amount because we don't want to write anything if the list isn't large enough. Alright, so then we write this integer, so light UBO.write element, template variables unsigned int, and we just pass in a reference to number of point lights. And then we'll have a counter here, so unsigned int I is equal to 0, defining this outside of the loop for a reason that we'll see in a second. And then the for loop will be for blank first condition. Then I is less than number of point lights, I plus plus. And then the process here will be similar to the directional light. We're just going to be writing the corresponding values, except this time we need to access the corresponding element from the array. So the first one will be light UBO.write element. Type is going to be glmvec3, and then we pass in a reference to point lights at I dot position. Alright, and then once we finish the loop, we want to advance through the elements that we did not write to, so we can use the function light UBO.advanceArray, which just advances a certain number of elements through the array. We put some thought into this method, so make sure you use it, get your value out of it. And the number of elements that we want to advance is going to be the maximum number of point lights, so the size of the array minus I. So this is just going to be the leftover elements that we did not write to. And then the process will be almost identical for the spotlights, except we just have a few more values to write to. So we'll do something similar with the number of spotlights. Number of spotlights is going to be equal to the standard minimum template variable of unsigned int, and it's going to be spotlights.size and max spotlights. And then we write this, so light UBO.write element, unsigned int is the type, reference to number of spotlights. And then the for loop, it's going to be for first condition, or the first statement is I is equal to 0 to reset the counter. Then I is less than number of spotlights, I plus plus. And then we just want to write all of the corresponding values. And then to round it off, we're going to write the array container for each spotlight for the, so it's going to be a glm mat4 as the container type, and then glm vec4 as the element type, and the container will be a reference to spotlights at I dot light space matrix, and then there will be 4 vec4s in that. Alright, good shit. Alright, so after that, we can go now into main.cpp and we'll update the code. This is just pretty simple, just so that we can actually use this. So I'm going to go ahead and take the UBO code that we have right now, and I'm going to delete all of it, just because we don't need it anymore. Just like that. And then you're going to have one error, which is the call to prepare, because we don't actually pass a list of shaders, and all you got to do there is just pass in an initialized list containing the default shader, which is the shader that we use to render all of our objects to the default FBO. Alright, so the one thing I did forget to do was that in the last video we played around with some matrices in the vertex shader, so just make sure to remove those because we don't set them anymore. So it will just be outputting some stupid value that we do not want to see. So if we run this now, we should get everything that looks the same as before. And yeah, so now that we have integrated our lights into our UBOs, it will be a little it'll be a little more efficient to write to it, one, and then it'll also make swapping out the lights a little more intuitive, and it will simply just make things a little cleaner in the code. And then this will also help us when we want to play with some of the lighting values, the positions in the vertex shader, which we will be doing in the tangent spaces, which is why this was necessary to take care of this in the UBO. So yeah, this was just a quick, or I don't know how quick it was, but it was a video on just integrating the final part of our UBO video, or UBO mini series, in integrating the lights into the UBO. So now that we can play with it however we want, and then tomorrow I will be finishing up streaming the tangent faces, which will be the kind of the culmination of all this stuff, combining the UBOs with our existing normal mapping, which will be fun. So yeah, until then, enjoy yourselves, and I'll see you then. Have a good one.